Hello everyone, welcome back. Welcome to this machine learning series. My name is Gilbert Aliho and I'll be taking you through this session, regression, and I'll be able to understand what regression is and do some practical bit part of it by doing what? By modeling a regression model. So basically, regression is one part of supervised learning, and then it is the easiest part of supervised learning that you're supposed to understand and know very well. So you're welcome to this party. Hope you're going to enjoy. So the learning outcome is that I will be able at the end of it all to understand what regression is and how to know if the data is fit for regression test, preparing the data for a machine learning model, and then training machine learning model with linear regression, decision tree, random forest, and then understanding how these algorithms do work. So regression in machine learning, like we have said, is that lies under supervised learning. Is a technique whereby you want to predict the continuous numerical value, like you're trying to predict some value depending on some independent features. You might have one or more independent features. Independent features, what you're trying to mean is that you're using something to predict something else. Like you're having uh something you're basing on predict another thing. So that the thing you base on is what we call a independent feature. Like for example, you may want to predict whether it will rain tomorrow. You predict you see you base on the month that we are in, and maybe even if it rained the previous year, and then you can say it's likely to do what? To rain. So it finds relationships between variables so that predictions can be made. And under regression, we have uh, the variables we have when we are dealing with modeling, the variables that are dependent and then the independent. Like the dependent one is that which you are trying to predict, a continuous value that you want to predict. And then independent variable is this what? Input that you give to your model to do what? To make a prediction. The features that you already have. So the dependent are just the targets that you're going to predict. And then there are some types of regression that you may see. Okay, there's some algorithms that you may use, and these sometimes are classified like types. There is a simple linear regression whereby maybe an example that I've given you, you want to predict whether it will likely to rain tomorrow. So you base on actually one feature, like the month we are in, and said because of the month we are in, it's likely to do what? To rain. So that's simple linear regression. And then with linear regression here, you're trying to fit your model along, let's say, like a straight line, and then you want to predict basing on the what? On the linear relationship between them. And then you say maybe because due to the what? You can say that due to the situation that you're in, it is likely to do what? To be like this. Putting it in real world. Uh, you can give an example. If a relationship is linear, we are trying to mean is that at times you find uh, some situations increase or happen due to some other situations happening, and then you find that something cannot happen without the other occurring. So it's like someone who is trying to do what? To predict the price of a house. So meaning you have first to know, like, if you're using the number of rooms in that house. So meaning as the number of rooms increase, there is also the what? Possibility that the price of the house might do what? Increase. So there is that linear relationship between the what? The two features. So that's why we're saying that we use linear regression. And then remember in high school you used to plot graphs, and you find you're drawing the line of best fit. So your model will try to predict values, and then basing on that line of best fit and then calculating the error, depending on that line of base fit that has fitted on the what? On your data. So with simple linear regression here, you're trying to use one feature to predict maybe like the house of the price, maybe the price of the what? Of the house based on, like, for example, needs says it. And then multiple linear regression here extends simple linear regression by using more than one what? Independent variable or more than one feature. Like, you depend on the size, you depend on the fashion of the house, you depend on the location, the distance, and then the rooms, then you can be able to do what? To predict the what? The price of the house. Then there are cases whereby you find the situation is not linear. Then there you can comes in what we call polynomial regression. If you find like there is no much linear relationship between the what? The features. Maybe you find, for example, the house has 5 rooms, but the distance is far, very far actually, and then you find even the what? Maybe you're considering even the location is not too much good, and then there is that non-linearity between the what? The variables, and then you're trying to figure out ways where can I predict the price to be in. The location is too far, and then remember we were saying that maybe little location, less location distance might you be used to predict the price at a maybe higher price, but now the location is far, the rooms are what? Are many. So there is that non-linearity between the what? The features. So you use a polynomial to be able to fit that data very well. So that's where polynomial regression comes in. And then there is also the random forest regression. So basically with random forest regression, actually what you're trying to mean here is that you're using a random forest regressor, like an algorithm, but you're using it maybe on linear data, or you're using it on complex data, then to be able to find the relationship between those two. Just you're using the algorithm, and then that's why we're calling it random forest. Even the decision tree, it's not that they are different in that you apply other techniques, only what makes them different is that the algorithm now becomes a decision tree regressor that you just implement. And then the same thing that applies to the support vector regression. It's not that it's another type of regression, but it's just that we use another type of what? Of algorithm that we feed to our what? To our data. So like above there on the linear regression here, we use a linear regression model, we feed to our what? To our data, and can be able to find a partner in our data. The same thing applies to random forest. We fit a random forest regressor into our what? To our data, and can be able to find the what? The relationship, and then predict the what? The value that we do what? We do want to get. And then how do we know that our model is performing well? We use these regression metrics, the MSE, and then RMSE. So with MAE, we just get the difference between the predicted value and then the actual value. Let's say that the actual price of a house is 300,000, and then the model predicts 400,000. So what with the MIA, what it does, just gets the absolute difference of the between the two. With absolute meaning is that even if it's negative, it must be made positive. We get the difference between the two, and then if they are more than one, then you get the average of the what? Of those two. So the same thing with mean squared. With mean squared here, we get the square difference. So the difference you get, you what? You square it, and then you calculate the average, and you're able to do what? To get your error. Then the root mean squared error, that's the what? The square root of the what? Of the above one, which is the mean squared error. Then the Huber loss here, we just use a loss function that transitions from mere to mesh for larger errors, providing balance between robustness and what? And then the error score, error2 score, then here we are trying to indicate whether our model is fitting. The fit is ranging between 0 or what? or 1. Yeah, we shall see this in practicals as we continue to dive more how we can implement them. So how do you know whether your data shows linearity? Basically, it's not just that you get data from anywhere, from cargo, from where, and then you just use it maybe. Just have to first understand if your data you're using is able to have some that linearity that you will use, that will guide you how to predict, not even use, that will guide you when you're doing your modeling. So what happens is that you might need to inspect your data visually. For example, you might plot your future x and your target y, and if the point roughly form a straight line, then linear regression may be suitable. And then maybe let's say study hours and then exam score. If the plot looks like a line going up, it's linear. And then for multiple features, plot each feature against the what? The target, x versus y, x2 versus y. And then look for the linear trends in each what? In each plot. And then you can also use a correlation. This was Spearman's correlation, if you still recall it in high school. You used to do that math, and then so with correlation here, uh, if something is correlating to another, it must give you a positive one or a perfect negative one or a perfect what? Positive one. So so what happens is that you use a correlation method and then you apply it to your what? To your data, and then after applying it to your data, you just do what? You just call it and then you say, do for me the correlation of this so that I can, depending on this target actually. You give it even the target. It does for you the correlation depending on the target you do what? You give to it. And then if you get values, let's say the correlation that will give you on each every target, you find you're having 0.5 and above. In most cases it is 0.5, 0.7. So you find there is a what? A linear relationship. That tells you there is a linear relationship between the two. Even if it's negative, it might be in a reverse way, so it doesn't affect that. So you need also to use the correlation of by visually doing what? Plotting each value against the other. And another thing now, so this takes us to, after understanding the relationship, this takes us to cleaning our data. So how do we clean this data for the machine learning algorithms? What do we mean by cleaning? With cleaning, we mean like, let's say there are missing values in our data, so we need to take care of that. If there are characters, categorical data, we need also to put it into numbers so that we can give it to our what? To our model. So with missing values, one of the things that we might do is that drop those columns that have missing values. And then, for example, you're seeing this diagram of two columns, the bed and the bath. So you might try dropping one and then you remain with the other. If at all maybe the columns you're using, the columns that have missing values are not useful, you might drop them. But if they're so useful, then you will go for this second option, which is imputation. So with imputation, what it does is that it tries to fit every column that has missing values with a what? Maybe with maybe a median of that column. You might calculate a median maybe for that column, then you fit it to your what? To your missing space, and then you fill it in there. And then you can see with a bed, it had some missing value. So you calculate the what? The median or the mean, and then you put it in there. And after that, you're able to progress and then give to your model. So that's the case of missing values. So if after taking care of missing values, what do I need to think about? The categorical columns now that you find in your data. So with categorical columns here, what we are trying to mean is that there are some cases you find that users data is form of text. Let's say maybe consider a survey that asks how often you eat breakfast and provides four options: never, rarely, most days, or what? Every day. So if you want to predict maybe how much someone consumes, So you find that you have data in this form of categorical data, and you need also to convert it into what? Into numbers. So here you need to take care of that. And maybe if the user people responded to a survey about which type of brand of the car they own, the responses will be fall into categories, maybe Honda, Toyota, Ford, Mercedes Benz, what? So there will be many categories. So there are some with categorical data, you may find this data is in order, and then you may also find that the data you're dealing with is not in what? In order. You'll get an error. So if you try plug these variables into most of machine learning models, so you have to first pre-process them. So this takes us to how do we process these categorical columns. The first thing is that you might need to drop them if you feel like it's necessary or worth it, or they are not of use. So you might drop them, which is also okay. And then, but I don't recommend dropping columns, or maybe anyway, it may be helpful if you feel like the dataset you're dealing with has very many features, and removing those few won't affect you. And then there is also what we call ordinal encoding. Now, with ordinal encoding here is that it works with categorical data that has order. Let's say now this column of breakfast, as you can see, it has some order. The categories are within maybe a certain range, and then maybe breakfasts every day, have breakfast every day, or maybe never, rarely, most days. So that could be different people. So with ordinary coding, what it does, it assigns each unique value in there with a different what? Different integer. With unique, what I'm meaning is that if I'm having different categories, meaning I'll have give them different numbers, but if the same, they'll have the same what? The same number. So that's what ordinal encoding does. It gives them unique what? Unique values, and then meaning you have to drop the breakfast of categories, you put the breakfast of what? Of numbers. But now what if the data has no order? Like you find, for example, here we said if you're asking a drivers about the cars they own, you'll find you have data that is Ford, you have data that is Toyota, Honda, what, very many. So what do you do? Now with this, what you do is that you apply what we call one-hot encoding that deals with data that has no what? Has no order, but it also has a limitation. Like if you find you having a lot of categorical unique categorical data in the what, in the column, you find this induces more what, more columns. So with this, the more the more unique the more unique categorical data that you have in each column, the more the what, the columns it will induce. Like it will create more columns on the end. So for example, now the red, the yellow, the green, they become new columns, and each represents what? An occurrence of that what? Of that color. If it's red and we under red, meaning it will be 100 what? 0. And if it's yellow, it will be 010. And if it's green, it will be 011. So meaning the more the unique categories you have, the more the what? The added columns that will come in. So one-hot encoding creates new columns indicating the presence or absence of each possible value in the original data. And then that's what really happens with how you prepare data for your machine learning model. First of all, you have to take care of missing values, and then categorical columns. And then also you have to inspect about, like if you find you need to look at good features that you might use. So all those you have to look them through. But with cleaning, these are the main things that you put into. There is also binning, which we shall see in the days to come. Yeah, for now, first understand on one how we clean this data using one-hot encoding. So this takes us to our first part where we shall do the hands-on. We are going to use a data set. This data set is from This dataset is from cargo, and then we shall use it to do our modeling. So before we start, we have to go into cargo and then get our dataset, and then put it into our field. Can be able to proceed, and then so you go to cargo, and then you search for cargo. This will bring you to this tab, and then you log in. If you don't have an account, you first log in, and then after logging in, you'll go to datasets, and then you search for Melbourne housing. So it will bring this Melbourne. You download this. Let me see. First wait, and I see. Yes, you download this one. Yes, you download this very dataset, and then to be able to download, you just click on this download here, and then it will start, and then you click on this download dataset as a zip file, and then after clicking there, it will start downloading automatically. So after downloading, what you do is that you go into this downloads, and then you extract it, because it comes as a zip file, and then you extract files, and then it will ask where should it extract, and then go. So may just want to leave it in this downloads, meaning I'll just press OK, and then it extracts, and then it will put it down here. You can see it is archive 1. So you copy it, you can put it in where you want code from. Okay, before you do that, then you open your Anaconda. Mine is already open. You search for it there, then open it, and then under Anaconda you launch Jupyter Notebook. As it is launching, okay, launch your Jupyter Notebook. As mine is coming, I'm still waiting mine to come. Okay, why is it not bringing it? Let me check. Okay. Okay, now it has opened. So it will open this notebook for you, and then you have to create a folder. Maybe let's say this is I want to come here and say new folder, and say maybe session 1. Okay. Where is my folder? Yes, it's here, session 1. So in here, I'll have to put there the data that I was talking about. Let me come here and get my data. It is called archive 1. Double click in it, there is Melby, then copy it, and now I have to put it in my Anaconda folder that I've created. Okay, let me just do it from the browser. Sorry, my real. Let me copy it again. Copy, and then I have to look for where my. Let me first come back here on home. Okay. It was in downloads. Okay, it was in downloads, and then it is called archive 1, I think. Yeah, so it's here. Okay, so I'm going to just copy it and then take it into session 1. Okay, it's there now. And then this one, I just want to get it out of this folder. Let me just put it here on top. Now, I'm doing this so that when I'm looking for my data, I don't need to suffer. So wherever you're coding from, make sure your data is near, close to you. So here you just have to open a new notebook, and then you start doing what? Start coding. So due to the issue of time, I'm not going to do it. I'm just going to explain my code that I did, and then can be able to follow up also. So feel free to pause and then type this code and then try it out on your own, so that you learn, not just cram. So let me first look for my code here. Is machine learning. So this is my code, sorry, that I've been using. So as I told you, you need to first learn Pandas, and then after learning Pandas, sorry about that. So I told you need to learn Pandas. After learning Pandas, you learn Matplotlib, you learn those libraries so that you can be able to do what? To apply them as long Seaborn, and then the rest will come on the way. So you can see I'm starting with importing Pandas. After downloading it, I put it, and then I give it an alias which is pd. Then matplotlib.pyplot, I also give it an alias which is plt. Then Seaborn, I give it an alias which is sns. And then now what I do is that I'll create a variable called melb, and then I use pd, and then read this comma separated data that is called melb underscore data, because this is the name that is given to it here. You see it's its name, and then I do what I call it. So I read it in form of, when I say read a CSV, and then I'm using a PD, meaning I'm reading it in form of a data frame. So it will bring it in form of what? Columns. So let me run my code. and then it runs and then reads it. After that, if I want to get insights after on my data, I just need to use this info keyword, and then here what it brings for me, it brings for me the entries that I have in my in my data. It tells me that I have from 0 up to 13,550 579. So it tells me that it has all these columns that exist in there, and then you can even be able to see that some columns don't have the same number of data, meaning there are some missing values. Like these are the rows. So this tells you that you have 13,580 rows. But now of these rows, there are some that don't have the same number of rows, meaning there are some missing data. And then the data types, it tells you that there is float with 12 columns, and then there is an int with 1 column, and then the object. You can see that now the objects, now we have method is an object, sellergy is an object, cancel area is an object. So that's it with the with the info. So now with describe, this one gives you statistical data about your your data. Let's say you want to see the median, the mean value, the maximum, the 50th percentile, how data is distributed. So you just use this describe and then get the insights about your your data. So now what if you want to check for missing values? You can also use this small method here. Can give you very well the missing value. It tells you that under price there is nothing like a missing value, and under car there are 16 missing values, 62, and then under building area there are 6,450 missing values. So you need to take care of that. So this gives you an insight and say, now I have a lot of work to do. So this is, you just say melb is null and then dot sum. So this what it does, it counts the null values in that particular column, and then is sum, you're combining the total number of missing values in that particular column. So this is just as simple as that. Then you just specify the variable referring to that is storing your data, and then you call is null onto it, and then is sum onto it. Sum onto it, and it's able to return for you your missing values. I'm commenting them out so that they don't become too long and then may disturb us while you're trying to see them. And then this one now here, first of all, remember we said that there is a dependent variable and independent variable. So meaning I have to first know my dependent and my independent variable. So like we said, the dependent variable is the target, the dependent, something that you're going to predict, and then the independent, those are things, the features you're sticking onto to predict something. So when I do this here, I'm just going to drop. Remember, my MailB has everything. So if I want to predict price must not exist in the in the independent column, in the independent tables. So meaning I'll just have to drop price from all this and then put it into X. So my X will have all the columns without price, and then my Y here will have only price, and then I will use price. I'll use this X to predict the price, which is the target. That's why we're saying melb.price. So if I say melb.price, it's like I'm just saying my mail B should have only the price column, and then you can try visualizing using this, and then you at least call the first five the first five column rows in in that data set. You can see there is no price in these columns. Price is not there because we dropped it, and then you can see there's some categorical data in your data set. And then You can also check on the Y. First comment this. So you can see with the Y it is saying you have there these braces. So after that you need to split your data set. With splitting here, remember when you're training your model, you need to split your data set in a way that you have your training data and then your testing data. And then you must also have your validation data first, because after you training your model, you need to test it using the validation data and see how it is performing before you give it the test data that you gave it and sim data. So you just have to use a train test split that is used from from Scikit-Learn, and then from sklearn.model selection. So this is like a package. You just import it. You just import this class from this package here, model selection. So you just have to go to Scikit-Learn here, and then you go to API. Okay, it's like I have some issues with network here. So I would recommend you that when you're doing machine learning, also refer to the what? To the documentation, to the website of Scikit-Learn and get more insights from there and see how things are doing, what are working out. So just have to go to sklearn. You just have to go to your browser and you search for sklearn. Sorry, Scikit-Learn. And then it will bring it for you. Automatically tap on it. So when it brings this, you just go to API, and then so you can see all the different things that you may need to use are listed here. And then remember in our code we are saying sklearn.model selection. So let me look for model selection here now. Where is model selection? So it's here. And under model selection, what is lying there is that we have splitters that we may use to do what? To split our data. There is a train test split that splits arrays or matrices into random train and test what? Subsets. So this is what we are doing in here. And then when you're trying, you just create variables, the x test, x train, this and this, so that when you split your x will go into this one, and this x test full, and then this x train full, and this x test. And then when you split your y, it will go in these two here. And then remember, with machine learning, the you use 80% of the data to train your model, and then 20% to evaluate how your model is learning, how it is performing. So that's why here we are saying the train size is 0.8, and then the test size is what? 0.2, then the random set is 0. So after that, like we said, we need some validation data. So validation data is got from the training data. Again, I split my data again, and after splitting, I split now. This time around, I won't split my X and Y. I'll be splitting this training data. It's where I'll get my validation data that I'll test my model after training it before I give it the real test data. I'll test it using the validation data and I will get it from this X train full and then the Y train full. And then the random state is the same, and then the train size and the test what? The test set. So you can check for missing values by using these same methods here. The X test. Now you can check if in your test there are some missing values using this. Let me first run this. I had not yet run. So you can check for missing values using this. You can see in your test data there is a lot of missing value. So when you're going to test your model using this data, you also have to what to clean it. So that's with it with the tested data. So you can check even for this. Remember now you can also check for this Y train and the X train and see if there is some missing values. So it is telling me in my Y train there are no missing values and in my Y value there are no missing values. And then what about in my X train? Is null dot sum. Okay, this is supposed to be okay. Now we're seeing even in our X train there is a lot of missing values. So where does this take us? Meaning now the X test has missing values, the Y test has no missing values, this has missing values, and even my X valid must be having missing values. Let me first check. Let me first comment this and run again. So you see even in your validation data has what? Missing values. So meaning you have to clean the training data that you give to your model and then the validation data and then the testing data. So basically the way we clean this data is very different. Like categorical data is cleaned in a different way and then numerical data is cleaned in a different way. But now our data set, our X train has categorical data and it also has numerical data. So and the same thing applies to my X valid. It has categorical data and numerical data. To prove use data, let me first call this one here. Let's check in our X train what is really there. Let us check. So you see in our X train there is numerical data and then categorical data, meaning there is need of doing what? Of splitting it. So we shall split this data, we shall put the numerical data separate and then the categorical data also separate so that it doesn't cause what we call issues. So I don't know. So we shall separate this data, then we shall only now here select the object type. Like on top we saw that there were objects and then they were what on float when we were using the info. So here under num I'm just going to select and then I'm selecting. Remember here I want to put the only numerical data. So when I do the selection bit part here is that I'll exclude the object which are the categorical. Even under the cat I'll exclude the float to remain with only numbers. Yes. So this was some visualization which today we're not going to look at. Our aim today is about these two. So let me first go back here. Our main aim is about cleaning today. So I need to first understand this and then the rest will come. So this is where we were. So if you want to separate this and now we separate them here, we remain there with Sorry, are we here really? Okay, we were here. We said that we need to separate our X train. We put the numbers together and then the categorical together. And after that, we combine them together. So when we are selecting, we use these select data types and then we exclude the object. Remember here, one there numerical and then categories there. And then the same thing applies to the X valid. You also select and then you separate the two. So now when we are going to pre-process, we apply we we apply the simple imputer, applying the simple imputer on our X train here. Meaning now with this, remember with imputer what we said is that wherever there is a missing value, just fill it with maybe let's say the median of that column. So we cannot apply the simple imputer on category data. So meaning this numerical data will be worked on it alone. So I will just have to, from this package here, I look for my simple impute and say from sklearn impute, the same thing like we did here. If you go to Scikit-Learn, you under API and then you search for that missing values, then you'll be able to can get it very well. So from sklearn impute, import a simple impute, and then from sklearn.preprocessing you import the one hot encoder, and then you apply the simple impute on your X train now. And then with this, you first instantiate and then you specify, maybe you call it, maybe you create an object. Let's say this is a variable num imputer that will store this object, the simple impute, and then you provide the strategy that you're going to use. If you want to fill in missing value using mean, here you'll put mean. If you want to use median, you use median. And then after that, let me first run these columns here so that and then after that you apply this imputer here. But now with imputation may cause some distortion of your data, like your data might get distorted. That then here, to be able to avoid that, we use a data frame again that brings this data in form of columns again. So we apply a pd dot data frame, and then we call num impute, and then we say fit transform. With fit transform, what we are meaning is that the fit, it tries to fit that data, calculates the median, and then it transforms that data by filling in those missing values with the fitted, the trained imputer, with the fitted impute, and then fills it in there. But with imputation, what it does, it removes column names. It removes column names, and then to be able to put those column names back, you can try running this before you go to this. You try doing this and then you check for yourself and see you've not find that these column names. And then to be able to put the column names back, just say imputed this variable here dot columns. You give it the columns of the X train num here. You say since the columns of this must be equal to the columns of this, and then the column names must be equal. So you just say imputed X train num dot columns is equal to this dot dot columns, and you give it the the columns. And you can also verify after doing that by checking the head and then checking if there are missing values. Remember we said that we are working on subsets of X train, and then our X train we separated it in X train num and X train cat, and the end of it all we shall combine them back together to get X train preprocessed. And then another subset now we shall work on it is that the X train cat subset, we also work on it with which is categorical. But now when we are imputing it for this time around, we are not using median, we are using most frequent, the mode. So the category that appears most, we shall fill it in the what, in any place that has missing values. And then we use even the one hot encoder now with, and then we pass it to that data. With one hot encoder, data comes back in form of a sparse matrix. Like we saw in our presentation slide that this data comes in form of, you see here, this data is being represented like uh, a what? Like in form of zeros and ones. So it comes in this form but without these column names, and then it is form of a sparse matrix. So to be able to overcome that, we use sparse output and we put it to false. And then handle ignore. So with handle ignore is that when we're dealing with new categories, you might find there are new categories and then we need to ignore them. So that's why I put that. And then now you first apply the imputation. So with one hot encoder doesn't work with missing values. So you need to first apply imputation, a cat imputer onto this data by doing the same thing using the pd.data frame. You fit it there, transform it there, and then since imputer removes column names, you put them back. And after that, you also, after you doing the imputation, now you do one hot encoding now. Like you do one hot encoding and then you fit transform it there. And after that, one hot encoder removes index, then you put the index back. After putting the index, then everything is done. Now all you're remaining with is to get the other imputed extrain num, combine it with one hot imputed extrain num cut, and form your whole extrain preprocessed. Now you've processed your what? Your extrain. And then how do we concatenate them together? We just use this pd.concat, and then you concatenate these two subsets that you have the one that was numerical and then categorical. You combine them back together, and remember to specify this axis 1 because you're referring to the what? To the horizontal what? Axis. You remember to specify that, and then ensure all columns that have a string type, and then you use this. And then if I try running this, it will do for me the what? The preprocessing. And then let me first let us first check what is really happening. So if I try running this, we shall see, as it run. Okay, yeah, it has run. We shall see that our data has been, categorical data is no longer anymore. We are no longer seeing the words, we are only seeing numbers here. And this is very, very what? This is what our goal is. And then you can also check if there's some missing values. You can see we don't have any missing values in there. So everything is well. So next, now remember we had the x train, we had the x valid, we had the x test, and we found all of them had missing values. So the next thing is that you're going to pre-process now the what? The x valid. But when you're doing this, you don't need to do what we call the fit transform again, because you've already trained your imputer, you've already trained it and it has calculated for you the median. So here all you just do is just you transform. On top there you fitted, but now here you just transform using the fit that you did the other top on side. So remember here on numerical, our simple imputer was called num imputer. So you just go here and say imputed x valid, and then pd, just call the other num imputer, and then you transform this. So the num imputer is already trained on the other training data, and then it knows that when I meet this, I'll fill in that median, and then it fills it there. When you use fit transform here, let's say you put fit transform, if you dare do this, you're doing what you call data leakage. Your machine learning algorithm will be able to understand there is, like, it will be able to remember, we want to to know how our model will perform on new data. So when you put fit transform, your machine learning algorithm will have done what? Will have a glimpse on the data that is is unseen, and yet that's not our our goal. So we don't need to specify here the fit, we just need to put the transform. And then you can also go on and put the columns again, and then the numerical bit part of the x valid is done. And then the same thing applies for the categorical part of the x valid. You also just put the transform. You use again the other cat imputer on top, and then you transform it and specify, put the columns there, and then you also do one hot encoding. You transform, you don't fit, you just transform, don't put fit transform again, and then you put the index back. After all that is done, you concatenate them together, the x, this x imputed x valid num, and then the one hot imputed x valid card, and then you form your x valid preprocessed. Let me run this. So after that, you can also verify by running this code here, and then this is your x valid. It's not the x train. This is the x valid that will be used to validate your your model. And now after that, you've really trained your machine learning. You've really prepared your data, and now you only your remaining with is to do what? To train your algorithms, and then you can be able to feed them that data. So now with let us start with a random forest regressor. But before that, we need to first understand the decision tree and then the linear regression. We shall come back to the random forest regressor later on. So with linear regression, what we said is that I tries to feed this data on a straight line and tries to predict the value basing on the straight line, and calculates the error between the distance between that prediction and then the straight line. And the way to get the linear regression is just say from Scikit-Learn linear model import linear regression, and then you say linear regression, and then after that, this variable here that you use that is storing your linear regression, you just fit it to the x train preprocessed, and then the x train, the y train, the target. Yes, our target, remember on top when we were split it, our target was what? Was x train, this x train here, it was x train. So you do that, you just fit your x train preprocess that you've processed, and then you give it your x train, and then you'll be able to see this that it has finished doing what? Training. So you can run that, and then now with a decision tree, this one works in, of course, I think you know how, I don't know if you know how a decision tree works, but with a decision tree, it's like it a file structure of of a computer system. Like you start from maybe C, you go to folders, you go to B, sorry, you go from C, is it C drive? From C, you go to users, maybe you go to admin, you go to this one, you go to this one. So with that, so the decision tree also follows the sum hierarchy. Like it has a root, it has the nodes which you call maybe the leaves, and then it has maybe the what? The what? The other children down. So that's how a decision tree, it has some start that it starts from. So if I'm using a decision tree, just use it from, if I call it from the tree, sklearn.tree. The linear regression is from linear model. And then the decision tree is from what? Tree. Just say import decision tree regressor. The reason that's why you're saying regressor is that decision tree can also be used for classification. And if it was a classification, we would say decision tree classifier. And then you instantiate it in here. But now our decision tree must have a depth. How far can it go? But may just want it to have only 5 what? Only to go down only 5 steps. So that's why I limited it and say only 5. And then you fit it on your what? On your X train and then your Y train. And after that, you also run it, and then it will be able to do what? to do for you what you want. So, and then if you want to predict, you just use this method called predict. Here, when you're fitting your model, just use fit. But with predict, you just use this predict here. And then when you're predicting, you pass in the validation data. That's why we say that we want to test how our machine learning model, sorry, our algorithm is performing, our model is performing, but we want to test it on validation data, not the tested data. That's why we separated it, and then we give it the X valid preprocessed. And after that, we shall get the error. And before that, let us first visualize this. I'm using this so that I could bring in the visualization of the decision tree, how it is working. Yes. So I use this library called export graph visualization. It is also under tree. And then I imported some libraries. I installed them from here. You can say install pip, install ipython. I also installed the dot plus. You have to first install them so that you can be able to visualize this decision tree here. So, and then when you specify the tree that you've trained on top here. It was tree. That's how we called it. And then output file, you just have to just specify no, and then the feature names, you specify the column names of the data you're passing to it. Now remember, now what I want to visualize how the X-train preprocessed is being distributed in form of a tree. That's why I'm putting here the feature names as X-train preprocessed. If you want to visualize this prediction here, you can also put X valid preprocessed dot columns, and then you fill with filled. Now here we want these nodes here to be filled with column names. And then you say graph, then you use this method graph from dot data. It converts this dot data into into a graph. And then here with image, now you want to convert this image into a form of a visible image. So let us try to see this. This is my decision tree. I don't know if you can see it very well. So this is my decision tree here on top. The space is not enough, but we shall try to see it anyway. Yeah, so it's here. It's starting from the rooms. It is using the rooms feature, and then rooms with less than 3.5. The house with less than 3.5 rooms will go to the left, and then the house with these rooms more than this will go to this side, and then it shows even the samples that it is applying to, and then the value. So it goes on and then does that for all until it reaches to the extreme end. So this is a decision tree, and basically that's how it works. You can see it very well here. It is form of bases on some. You can go on and go in deep and see how it splits this data, and can be able to get what you want from there. So I don't know if my linear regression mode has finished training. I think it is even still training here. See, that's how it takes. It takes long to train a model because of depends the strength of the PC. So that is it with a decision tree, and then with a mean absolute error. So how do you get the mean absolute error here now? So what you do is that you go to matrix, you get this mean absolute error here, and then with mean absolute error you specify the prediction and also the target, the real value. Now that's why the y valid comes in, and the prediction, they come in from this, and then you pass them together, and then it is able to get for you the score. The same thing applies to this. you pass in the y valid. For here, I trained 3 models. I trained this random forest, I trained a decision tree, and the random forest. So with the random forest, what it does is that it combines more than one decision trees, and then the predictions of the two are combined together, and then it can be able to give you what you want. So you can go on and research more about this. So with the random forest, you just get it from sklearn.ensemble, and then can do that. I think for the rest are very easy for you to understand. This is here I have some error because uh, I need to rerun this code, and it is taking very long to do what to train. You see, even the linear regression itself hasn't finished training, so I can't rerun this code now because it will take a long of time. And then before you test, before you give this test data to your machine learning algorithm, sorry, to your model that you have trained, you have to first do what? To also pre-process it the same way we have processed the x valid, but now you don't need to specify the fit again, you just specify the what? Transform. So that's it. And how do we save our model? Saving your model, just you say import job lib, and then you specify the model that you're saving, which is maybe like model 2, and then you give it the what? The name. So basically that's it for today. Thank you for listening. Happy coding, and welcome again to the machine learning party.